In this video, I'm going to do a few more examples using the binomial distribution function. Right. So let's go ahead and read this example. The probability that a football player will get hurt in a game is 0.1. 10 players are randomly selected. What is the probability that exactly 3 will get hurt? So probability of getting hurt is 0.1. Well, first thing we need to recognize that this is a binomial distribution type of problem, that the random variable involved here is binomially distributed. And the reason that this is because, first off, we have a success or failure, right? There are two possibilities. Either a person gets hurt during a game or they don't get hurt during a game, right? And then there's a set number of trials. 10 players are randomly selected, so that means the number of trials is 10. And we're trying to find the probability that exactly 3 will get hurt. So 3 out of the 10, right? Another thing you need to consider is that all the trials are independent. So there's no reason to believe, given this information, that one player getting hurt will influence another player getting hurt. So it's reasonable to assume that each of these players are independent of one another. Okay? So that means that the random variable is a binomially distributed random variable, and so you should use the binomial distribution. Let me go ahead and write the binomial distribution down. So we discussed this, this function in the previous video. So this is what the function is, n minus x factorial times x factorial, and then this is p to the x, and then, I'm going to write a q to the n minus x. Right? So for our example, x, the random variable, is the number of players that get hurt out of 10. So you should always write your random variable as the number of successes out of 10 or out of n trials. So the number of successes out of n trials. In this case, a success is getting hurt, right? So x equals the number of players hurt out of 10. Okay, n, the sample size, is 10, right? 10 players were selected. And then p, the probability of success, or in our case, the probability of getting hurt, is 0.1. Right? The probability of getting hurt is 0.1. Then also we need q. Remember, q is 1 minus p, so that is 1 minus 0.1, which is 0.9. Okay, so now let's go ahead and plug things in and calculate this probability. So the probability that x equals, so the value of x that we're trying to determine is if x equals 3. We're trying to determine the probability that the random variable x, the number of players that get hurt, is equal to 3. Okay, so this equals 10 factorial, n factorial, and then n minus x, so 10 minus 3 factorial times x factorial, that'll be 3 factorial, and then p to the 0.1 raised to the power of x, 3, then q, which is 0.9, raised to the power n minus x, which is 10 minus 3. Right, so let's go ahead and simplify this a little bit. 10 factorial, let me go ahead and lower my window a little. So 10 factorial is 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1. Right, that's 10 factorial. 10 minus 3 is 7, so 7 factorial is 7, 6, 5, 4, 3, 2, 1. And then 3 factorial is 3, 2, 1. Okay, times 0.1 to the third power, 0.9, 10 minus 3 is 7, so it's 0.9 to the 7th power. All right, so we notice some cancellation here in this quotient. You notice that there's 7 times 6 times 5 times 4 times 3 2 times 1, and then also 7 times 6 times 5 times 4 times 3 times 2 times 1, so they cancel out. So you're left with 10 times 9 times 8 divided by 3 times 2 times 1 times 0.1 to the third power, 0.9 to the 7th power. So let's go ahead and pull out our calculator. Let me clear it out. Okay, so let's see. First I have 10 times 9 times 8 divided by 3 times 2 is 6. So divided by 6. Okay, that's 120. So actually, that means, remember this leading number here, 120? So that means the number of ways that I can, have 3 players get hurt out of 10, number of ways you can rearrange that is 120 different ways, right? So, the first 3 players out of the 10 could get hurt. The second 3 players out of the 10 could get hurt. And you could write a long list, and it would take you 120, different ways that the 3 players could be hurt out of the 10. Okay, so this equals 120 times 0.1 to the third power times 0.9 to the 7th power. Okay, let's pull out our calculator and calculate that. So 120 times 0.1 to the third power times 0.9 to the 7th power equals 0.057. Let's go ahead and write that down. 0.057. Right? So the probability that you'll observe exactly 3 players out of the 10 that get hurt is 0.057. Okay? I want to point out that there is a binomial distribution table that kind of can help you sometimes, so you don't have to actually calculate any of this. You can just look to the table, and the table is kind of like a calculator. I'm going to pull it up. All right, so this is the binomial distribution table. You see it gives the value of n, the value of x, and the value of p. Now, there'll be many situations where you will want to know the probability that x is equal to some number that's not here, right? Or you'll be interested in a probability of success that's not listed. That's usually the case. You'll be interested in knowing the probability of success, and it won't be listed here. All right, so you can only use this table in certain situations. Turns out that for our problem, we could use this table because we could look for n equal to 10. So that's here, n equal to 10. And then x equal to 3, and that's right here. And then p equal to 0.1, so that's this row right here, column right here. So that, where those all meet, 3, so n is 10, x is 3, and then p is 0.1. See right there, 0.057. Wow, that's nice, right? 0.057, which is our answer. So this table is kind of, it's a calculator basically. This table is a calculator. All right, let's do one more example, or another example. So players are selected at random. What is the probability that at least one player will get hurt? All right, so let's think this through. So still the same scenario. The probability of getting hurt is 0.1. Okay, so x is still the number of players out of 10 that get hurt. So, the possible values of x, so x could take the values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10, right? 0 players get hurt, 1 player gets hurt, 2 players get hurt, 3, or all 10 of the 10 get hurt, right? So what this question is asking us is what's the probability that at least 1 player gets hurt? So that means 1 or more, right? So the probability that x is greater than or equal to 1, right? So the total probability, if you were to add up the probability for all of these possibilities, it should add up to 1, right? So if I take 1 and subtract off the probability that x equals 0, then that should tell me the probability of all these other possibilities. Right? So if I take 1, which is the total probability if you were to sum up all of these probabilities, and subtract off the probability x equals 1, then that'll tell me the probability that x is greater than 1. Right? I'm actually going to use the table to find the probability x equals 0. Okay, so right here, n is 10, x is 0, and I'm trying to find, p is 0.1. Okay, so there it is, 0.349. 0.349. All right, so I can pull out my calculator. Let's go and clear it out. 1 minus 0.349 is 0.651. All right, so that's the probability that at least one player will get hurt. It's rather high, right? I just want to mention, so what I did is I used complements to determine this probability. Now, another way that you could do it is you could add up all of these probabilities, because x could equal 1, x could equal 2, 3, 4, 5. You could add up all of these probabilities, and that would also give you the same answer, right? So you could say, okay, what's the probability x equals 1? Add that to the probability that x equals 2, 3, or 4, or 5, or 6, all the way down to the probability that x equals 10.